acid, base, and salt, okay?
Okay.
So, so there are three acids that you need to know. Okay, hydrochloric acid, sulfuric acid, nitric acid. Okay,
Okay.
all right. So hydrochloric acid is HCl, sulfuric acid H2SO4, nitric acid is HNO3. So if you notice, they all have H.
Hydrogen.
Yeah. But actually, it's not hydrogen, it's actually a hydrogen ion. So, okay, if you write an equation, you dissolve this acid in water, it breaks apart to form hydrogen ion and chloride ion, hydrogen ion and sulfate ion, hydrogen ion and nitrate ion. Okay, can?
Okay.
Can you write this down first? Write down really?
Heaven.
Okay, you write this down because you're going to need it for later.
Okay.
Now, okay, hydrogen atom. What does a hydrogen atom have? If
Proton
hydrogen,
and
one
prot
proton
one electron. No
and zero,
neutron.
zero neutron. Okay. So what happens is, if this hydrogen releases one electron to form a hydrogen ion,
It
then
has
what
one.
then what is left in the hydrogen ion?
Only a proton.
Proton. So therefore, an acid, the definition of an acid is a proton donor.
Oh.
It's a proton donor because it donates the proton. Who is the proton? The hydrogen ion. Okay? So that's a definition of acid. So when they ask you what's a definition of acid, you cannot write whatever you want. You must write specifically this is acid,
A proton donor.
proton donor. Okay? So in that case, if you have a base, base will be the other way around. A base will be a proton acceptor. You get it?
So
Okay.
so acid donate proton and base accept proton.
Yeah.
Oh.
So what happens is, how do you know what's a base? So here's the problem. For acid, you will have the name acid. But for base, you got no name base. So basically, in general terms, all metal oxide and all metal hydroxide can act as a base. So who is a metal oxide? So for example, magnesium is a metal, magnesium oxide is a base. Okay? Uh, potassium is a metal, potassium oxide is a base. Copper is a metal, copper oxide is a base. Calcium is a metal, calcium hydroxide is a base. Potassium is a metal, potassium hydroxide is a base. Sodium is a metal, sodium hydroxide is a base. Copper is a metal, copper hydroxide is a base. So all of these bases are proton acceptors. Okay?
Okay.
All right. Now, So what about alkali? Then what's alkali? So now we go to part three. What's an alkali? An alkali is a soluble base.
So alkali is a base also.
Yes, alkali is a soluble base. That means a base that can dissolve in water. If a base can dissolve in water, it's called an alkali. If a base cannot dissolve in water, it's called a base. So for example, sodium hydroxide can dissolve in water, is an alkali. That's why it's in group 1 lah, alkali metal. So all the group 1, okay, so all the group 1 and some of the group 2, not all lah. So for example, for now, you just need to remember calcium hydroxide is an alkali.
So
So
group one
this
all.
group 1 all, because that's why it's called alkali metal. Group 2, some. Magnesium, some can, some cannot. So, but the most important is you need to remember group 1 can. Group 2, for now, you just remember calcium hydroxide because it's lime water.
Oh, lime water. Okay.
Okay? Can
Yeah.
you know what's a pH meter, right?
Yes.
Okay, so there is such thing as pH 0, but usually we just learn 1 until 14, and then 7 is neutral. So anything below 7 is acid,
Let's
anything
drink
above
pH
7 is
zero.
alkali, right?
Okay. Let's drink pH 0.
Okay, now 7 is neutral now. Okay, now what happens here is if you have pH 1, 2, and sometimes 3, it is what we call a strong acid. Okay, and if it's like 4, 5, 6, it's a weak acid. That means not so corrosive lah. Okay, I'm going to explain to you what it means in a while. Now for alkali, same concept. Okay, 8, 9, 10 is usually called, or even sometimes even 11 is a weak alkali. Then 12, 13, 14, strong alkali. But if question asks you, what is the pH for strong acid? Always say pH 1. What is the pH for weak acid? Always use pH 6. Don't go and find the numbers in between. Okay? They ask you what is a weak alkali, use pH 8. What is a strong alkali, use pH 14. Okay?
So just use the most extreme one now.
Yeah.
Okay.
So all of the ones that I taught you just now, the sulfuric acid, hydrochloric acid, they are all strong acids. Okay, and just now all the group 1, they are all strong alkali. That means they are very, very corrosive. Okay, so what happens is like this. HCl, is it an ionic or covalent molecule?
Covalent.
Covalent. Okay, it only becomes an acid when it dissolves in water. If I put 100 HCl molecules, it will dissolve to form 100 hydrogen ion and 100 chloride ions. This is called ionized completely in water. So a strong acid ionized completely will dissociate completely. So in that case, my concentration of hydrogen ion will be very high or very low. My
Hydrogen ion.
concentration of
High.
hydrogen ion very high. That's why it's a strong acid.
Oh. So acid is just something mixed in water.
No, acid can only show its acidic properties only after it's dissolved in water.
So if we take powdered HCl, it doesn't corrode
Not not
anything.
not powdered gas.
Oh.
You must make sure your surface is completely dry. Okay?
Wait.
Yes.
Okay.
Okay. Okay, now weak will be ionized partially. Lah. So these are the acids that can eat. So for example, ethanoic acid. This is vinegar. This is used to make vinegar.
Well,
Ethanoic acid. So if this is a molecule, it will ionize only partially and the equation is reversible. That means you only have 1% of hydrogen ions, very low concentration. So it's in the equilibrium. You will have a mixture of this molecule, this ion, and this ion, but only 1% will be this ion. Most of it will still be molecules. So the concentration of hydrogen ions are very low.
so it still can be reversible.
Yeah, it's still acidic. It's still sour. It can still react with base, but it's very low concentration.
Vinegar is the one you eat on, right?
Yeah, that's why I said it's safe to eat.
Oh, citrus acid. Okay.
Okay, can?
Yes.
All right. Now we're going to talk about reactions of acid. Acid plus metal, you get salt and hydrogen. Acid plus base or alkali, you get salt plus water. Acid plus carbonate, you get salt plus carbon dioxide plus water. Okay?
Okay. Okay.
Well, all right. Now, mm, so now, you remember all your formulas?
Yes.
Is that okay? So there's one clause. The metal is all metals except for those less reactive than hydrogen. So who is less
Uh-huh.
reactive? That means
The
not,
reactivity table.
yeah, not copper, not silver, not platinum, not gold lah. Okay, get it?
Wait, except for Cu, Ag, platinum, Au. Okay.
Now, I want you to write down, change these word equations to chemical equations. All right? Ready?
Yes.
Remember all your positive, negative, ah? Okay, so change this to, okay, so in potassium's hydroxide and sulfuric acid, what do I get? This is acid and alkaline. What's my salt?
Potassium sulfate.
Huh? And what do I get? What's the next thing I get?
Or
Plus water. Okay,
yeah.
so then, okay, so like this. For sulfuric acid, H2SO4, potassium hydroxide, KOH, potassium sulfate, K2SO4, and water is H2O. Okay, do you remember how to balance the equation?
Yes.
Okay, 2, 2. Get it?
Yeah.
Okay, so I'm going to give you a list. I want you to write down the chemical equations, okay? Let's look at this. Okay, good. You must call it copper 2 sulfate. This one, wait, make it bigger. So this one also you need to call it copper 2 sulfate. Remember this one? You must say no reaction. Acid doesn't react with. You remember that?
Oh, because it's
Uh,
copper, silver, platinum.
yeah.
Miss, if it didn't react with copper, it still can react with like copper oxide, all these things, right?
Yes, can
Just
base.
copper cannot.
Yeah. Is that correct? This one also cannot. You forgot. No reaction. Okay. All right. Okay. Good. Uh, okay. Yeah, let's talk about the next one. Reactions of alkali. What's that sound? Alkali plus acid, you already know. salt and water, right? All right, so now one more is alkali plus ammonium salt. You get salt, water, plus ammonia. Okay, can you write this out? I'm going to show you how to do this. Do you understand? I give
What
you an
is
example.
ammonium salt?
I'm going to give you an example. Okay, so sodium hydroxide is alkali. Ammonium salt is like ammonium chloride. Okay, so ammonium chloride is ammonium salt. Ammonium salt is anything with an ammonium ion. Remember, ammonium is a cation. We can't. So, okay, the salt is sodium chloride, water, ammonia. Can you try and change this to a chemical equation?
Done.
So, sodium
And
hydroxide.
NaOH plus NH4Cl is NaCl plus NH3 plus H2O.
Get it? Okay.
Yeah.
So anything which ammonia gas, it'll come out. Okay, now here's the thing. Acids and alkalis are all colorless. So acid, alkali, and water are all colorless. Okay, so because they're colorless,
Doesn't that just makes it more dangerous?
yeah, that's right. So in order to detect it, we use something called an indicator.
Let me drink this water. Exit inside.
So indicator you need to learn is three very important indicators.
pH indicator.
Yeah, methyl orange,
Oh.
okay, and then thymophthalin, And one more is litmus. Okay. In acid, in alkali, and in neutral. Okay. In acid, metal orange is red. In alkali, it is yellow. When it's neutral, it's orange. Thymoxylate in acid is colorless. In alkali, it's blue. In neutral, it is also colorless. Litmus in acid is red. In alkali is blue. There is no such thing as neutral. If you use a red litmus paper, you put in alkali, change blue. Red litmus paper in acid, it will still be red. So it depends what original color you're using.
Miss, but
Yeah.
if the thermophthalate thingy, the
Mm.
acid and neutral is colorless, then how you know it's
Mm.
acid or neutral?
That's right. You have to use. So this is just for titration. It's not for you to detect pH. For you to detect pH, you use something else. We use something called U universal indicator.
But when you think of it, litmus also what?
No,
Litmus,
but litmus doesn't tell you the pH. Yeah, correct. This is just for you to
methyl orange is the
do.
only useful one.
So to test pH, we use pH meter or we use something called a universal indicator. So universal indicator will have a whole spectrum of colors. See? The whole spectrum of colors.
Okay,
Can you see this color change? So universal
yeah.
indicator can only to test pH only. Now, remember just now you were writing the equation? So now we're going to talk about state symbols, okay? Okay. So if we do this right, this sulfuric acid that we use is aqueous. This potassium hydroxide is aqueous. The salt that we make is also an aqueous solution, and this is water, liquid. Okay? So if we write down the ions, right? These are all the ions present in that solution. When it changes to a liquid, it's no longer an ion, it's now a molecule. Can you see that? So when we want to write something called an ionic equation, We only write the ions that changes. So you see, sulfate is an ion, sulfate is an ion, no change. Potassium is an ion, potassium is an ion, no change. The only ones that change is hydrogen ion and hydroxide ion react together to form water. So this is a very important ionic equation. You always use it for neutralization of acid and alkali. Hydrogen ion in an aqueous state with hydroxide ion in the aqueous state become water, which is a liquid. And this is a 3 mark question. So this is a very important ionic equation here. Mhm. Yeah,
Okay.
you done? Sorry?
Yes.
Okay. All right. So, okay, last part for the day. All right. This is called oxides. So remember I told you all metal oxides are basic. Okay. Yeah. Okay, I told you all metal oxides are basic, right? So basically it's like this. Most metal oxides, such as magnesium oxide, sodium oxide, these are all basic. What does basic mean? Basic means it can react with acid to produce salt and water. Okay? And on the other hand, the other is a non-metal acid, a non-metal oxide. Non-metal oxide is all acidic. For example, sulfur dioxide, carbon dioxide, nitrogen dioxide. Are they all non-metal? Yeah. So a non-metal oxide can react with alkali to form salt and water. Okay? Get it? So a basic oxide, okay? A basic oxide reacts with alkali. Acidic oxide reacts with, sorry, a basic oxide reacts with acid to form salt and water. Acidic acid reacts with alkali to form salt and water. So there's one last thing which is called amphoteric. Amphoteric is an amphibian. Okay? Amphoteric is an amphibian. It can react with both acid and bases to produce salt and water. So there's only two that you need to remember, aluminium oxide and zinc oxide. Okay? Okay, can you write this down?
Yes.
So that's why sulfur dioxide can cause acid rain because it's an
Oh,
acidic oxide. Okay,
sulfur
so
dioxide is the one that causes acid rain.
sulfur dioxide, nitrogen dioxide,
Malaysia tak ada acid rain.
God, why not?
Is acid rain strong acid or weak acid?
Weak acid. It won't kill you like that, but it's still acidic.
Oh, okay. Okay.
Okay? Do you understand?
Yes.